Hello, I'm here to help you understand generative AI in logistics and transportation. Let's work through this material together. Our guide, Smarter Forecasts, a guide to generative AI in supply chain, shows how to move from guesswork to smart predictions. We will start by looking at why current forecasting methods are struggling in logistics, then introduce what generative AI is, and finally, explore its practical uses. This series aims to give you a clear, no hype guide to using this new technology for more efficient and resilient logistics operations. The first key point we need to explore is the breaking point of traditional forecasting in logistics. Your guide explains that most traditional methods rely on past data. They assume that past patterns in shipping volumes or route demands will repeat. But as the guide states, history is no longer a reliable guide. Think about sudden port closures, unexpected fuel price spikes, or new regulations affecting shipping lanes. These events have no precedent in your old data. So, models see them too late or not at all. This is like trying to drive a truck forward by only looking in the rearview mirror. It's dangerous with unexpected traffic or road changes. Another big challenge the guide highlights is unstructured data. This is information like news articles on port delays, social media posts about traffic jams, weather alerts for key shipping regions, or even reports on new regulations. These are human language, not neat spreadsheets of shipment data. These sources often give the earliest signals of change that impact transportation. But traditional logistics forecasting systems can't read or understand this. It's like having a team of dispatchers reporting back in a language no one at headquarters can translate. So valuable information stays locked away, leading to decisions with an incomplete picture. Inaccurate forecasts have real consequences for logistics, as the guide points out. They impact operations daily. When we get it wrong, we face stockouts, meaning not enough product at distribution centers, leading to lost sales and unhappy customers. Or we have overstocks, which means too much product in warehouses, tying up capital and taking up expensive space. This leads to high costs, like expedited shipping to fix a shortfall or paying for underutilized fleet capacity. It also strains relationships with carriers and partners. These issues directly affect a company's profitability and reputation. Finding a better way to forecast isn't just a technical exercise. It's a business necessity for efficient logistics. Now let's talk about generative AI. It's not just another algorithm. Traditional AI is good at finding patterns in structured numbers, like predicting a shipment volume for next month. Think of it as a powerful calculator for your logistics data. But generative AI is different. It's designed to understand and create content like human language and ideas. As the guide puts it, if traditional AI is the calculator, generative AI is like a smart research assistant who can read, summarize, and even brainstorm with you. It can read thousands of news articles, traffic reports, and industry analyses, understand their main points, and summarize them for logistics managers. This is a game changer for processing that unstructured data we just discussed. The technology behind generative AI is often called a large language model, or LLM. You don't need to know all the technical details, but it's trained on vast amounts of internet data, books, and reports. This teaches it to understand language, context, and how ideas relate. This means it can read a news article about a port strike in Asia and understand that this could impact shipping times for electronics companies in Europe, affecting your fleet scheduling or warehouse capacity. It connects these dots at a massive scale, much like a human logistics expert would, but with far greater speed and breadth. This ability opens up three main ways generative AI can help your logistics and transportation forecasting. Here are the three key areas we'll dive into. First, generative AI can read and understand real-time information from many sources. This allows you to sense changes in demand and transportation conditions as they happen, not weeks later. We will cover this in our next lesson. Second, it can create realistic what-if stories. You can ask it to simulate the impact of a potential disruption, like a road closure, on your specific transportation network, letting you test your response plans. We'll also cover this in the next lesson. And third, it can generate new, believable data when you don't have enough, which is great for planning new routes or warehouse locations. We will explore this in Lesson 3. This technology provides practical solutions, helping your logistics operations become more efficient and resilient. Let's recap what we've covered in this first lesson. We talked about how traditional logistics forecasting struggles with today's volatile markets and the challenge of unstructured data, like port news or traffic reports. We learned about the real business costs of inaccurate forecasts for transportation and warehousing. Then, we demystified generative AI, seeing it as a smart research assistant that understands language and context, unlike traditional number crunching AI. We also previewed the three main ways generative AI can transform logistics forecasting: real time demand sensing, disruption simulation, and synthetic data generation. This is about augmenting your expertise, not replacing it, in managing complex transportation networks. Welcome back. In our previous lesson, we covered why traditional forecasting struggles in logistics and what generative AI is at its core. Now we're exploring its first two practical applications for logistics and transportation. Seeing the future sooner, with advanced demand sensing for distribution needs and simulating transportation disruptions with what-if scenarios. These tools help you move from being reactive to proactive, building a more resilient logistics network. Let's dive into how generative AI makes this possible. Let's start with demand sensing for logistics. Traditionally, you might use point-of-sale data to plan shipments, but that's a lagging indicator. Generative AI allows you to listen to the market in real time. It monitors thousands of sources like local news, social media, weather services, and traffic reports. It sifts through all that noise to find signals relevant to your product distribution and transportation routes. This means spotting early warnings of demand shifts or potential transportation bottlenecks before they show up in your sales or delivery reports. It's about being proactive in managing your fleet and warehouse capacity. Generative AI isn't just counting keywords, it understands context and sentiment. For example, it might detect a growing number of online conversations about a new diet trend. If your CPG products fit that trend, it can flag a potential demand surge and even pinpoint regions with the most interest. This turns a vague trend into an actionable insight for your distribution plan. Your guide shares an example of a CPG company launching a new flavored seltzer. Generative AI analyzed social media and influencer posts to find which specific flavors had the most positive buzz in different cities. This allowed the company to adjust its initial distribution plan, sending more spicy pineapple flavor to cities like Austin and Miami, and more cucumber mint to the West Coast, avoiding costly stockouts and overstocks by optimizing their transportation and warehouse allocation from day one. Next, let's explore how generative AI helps with simulating logistics and transportation disruptions. Most companies do risk planning, but it's often static. It's a spreadsheet with risks and general plans. This doesn't show you how a specific event would actually unfold and affect your transportation operations day by day. Generative AI allows for dynamic simulation. Instead of just listing risk of a port strike, you can ask the AI to generate a detailed, narrative-based scenario. For example, a 3-week labor strike begins at the port of Singapore. This immediately impacts your 5 most critical shipping lanes and halts the movement of 20 key components. Your main competitor is rerouting their shipments through Thailand, which will increase their lead times by 10 days and cost 15%. What should you do? This makes the logistics risk real and allows for much more effective planning of alternative routes or modes. To do this, you provide the AI with a basic map of your logistics network, where your key suppliers are, the routes your products take, the locations of your factories and warehouses, and your fleet capacity. The generative AI then combines this map with its vast knowledge of world events, logistics, and economics. When you give it a scenario to test, it can simulate how that event would ripple through your specific transportation network. This lets you test your response strategies for alternative routing or mode shifts in a safe, virtual environment. You can see where your vulnerabilities are before a real crisis hits. An automotive parts supplier used generative AI to simulate the specific impact of a key factory in Mexico, shutting down for 2 weeks due to a hurricane. The AI generated a detailed report showing which parts would face shortfalls, when production lines would stop, and even suggested two potential alternative suppliers or transportation routes based on its industry knowledge. The simulation provided a clear, step by step view of the potential crisis for their logistics team. The team used this detailed information to build a robust and highly specific contingency plan for parts movement, turning a vague risk into a manageable scenario with a playbook ready to go. Let's recap what we've covered in this lesson. We explored how generative AI enables advanced demand sensing by analyzing real-time, unstructured data from thousands of sources, giving you early warnings and opportunities for distribution and fleet management. We saw how it turns raw data into actionable insights through contextual understanding, like the CPG company example. Then, we discussed its power in simulating what-if scenarios for logistics and transportation disruptions, allowing you to test contingency plans and build resilience for your routes and hubs. This dynamic simulation moves beyond static risk assessments, as shown with the automotive supplier. These are powerful tools for proactive logistics and transportation management. Welcome back for our final lesson in this series on generative AI in logistics and transportation. Today, we're going to cover another powerful application: solving the data gap with synthetic data for logistics planning. Then, we'll give you a clear, actionable roadmap to start using generative AI in your own organization. Finally, we'll recap everything, reinforcing the idea that this technology is here to augment your expertise, not replace it. Let's start with how generative AI can create data when you don't have enough history for your logistics operations. There are many times you need to forecast for logistics without good historical data. How do you predict optimal fleet utilization for a brand new delivery route? How do you plan inventory and staffing for a new warehouse in a city you've never operated in before? Traditional models struggle because they need past data to learn. You're often left with guesswork, using averages of similar routes or warehouses, which is often inaccurate. This is the data gap problem in logistics. Generative AI solves this by creating artificial datasets that look and act just like real data. It analyzes patterns, seasonality, and relationships in your existing logistics data from other routes or locations. Then you can give it specific parameters about the new situation. For example, the demographics of the new warehouse's service area, local holidays affecting traffic, or the type of products for a new route. The AI then generates a new artificial data set of expected shipments or resource needs that follows realistic patterns. This gives your forecasting models something solid to learn from, allowing them to produce a much more detailed and believable forecast than a simple guess. A great example is a fashion retailer opening its first store in a new city. Without local sales history, using simple averages from other stores would ignore the new market's unique characteristics, risking poor initial stocking and an inefficient distribution plan. The guide shows how they used a generative AI model to create a synthetic, one-year sales data set for the new store. The model analyzed sales from 10 similar stores, but adjusted for the new city's demographics and climate. This synthetic data gave a much more nuanced forecast. It predicted weekly sales patterns by product category, allowing the retailer to create a tailored initial stocking, distribution, and local transportation plan that better matched the local market, leading to a more successful launch and optimized logistics. Now, let's look at your roadmap to getting started with generative AI in logistics. This is a practical, low-risk path. Step 1. Start with a specific problem, not the technology. Don't look for a problem to fit the solution. Is there a specific transportation route where you always seem to have delays? Are you constantly struggling to predict the impact of new traffic patterns? Do you worry about a single point of failure in your distribution network? Pick one of these clear business problems for your pilot project. Starting small and focused is the best way to learn and show value quickly for your logistics team. Step 2. Assess your data readiness. You don't need perfect data to get started, but you do need to know what you have for your logistics operations. Ask, do we have 1 to 2 years of historical shipment data for this route or product category? Can we easily access related data, like our past fuel costs, traffic patterns, or fleet maintenance records? Is this data reasonably organized? And who on our team understands this logistics data best? Step 3. Explore tools and ask the right questions. You don't need to build a generative AI model from scratch. Many software providers are integrating these capabilities into their logistics tools. When talking to vendors, focus on your business problem. Ask, can you show me a demo solving a logistics problem similar to mine? How does your tool connect with our existing systems, like our TMS or ERP? What kind of support and training does your team provide? Can we start with a small, low-cost pilot project to test this out for our transportation needs? Step 4. Run a pilot and measure the results. A good pilot project is simple and easy to measure. For example, you could use a new tool to reforecast the demand for one transportation route for the last quarter. You already know the actual delivery times and costs, so you can directly compare the accuracy of the new forecast against your old method. But don't just measure accuracy. Also measure other business outcomes. Did the new tool identify a potential road closure or port delay that you had missed? Did it save your planning team time in optimizing routes? Proving the value is about more than just a percentage point improvement in accuracy. It's about making the entire logistics forecasting process smarter and more resilient. This initial test provides the business case you need to expand. Your first move? Open your calendar right now and schedule a 30-minute meeting with your best logistics planner. The topic: our single biggest transportation forecasting headache. That's where you start. In conclusion, logistics and transportation forecasting in today's world is tough, and the traditional tools we've relied on are struggling. Generative AI is not about replacing old methods entirely, but enhancing them with a new ability to listen, simulate, and prepare. We've covered its 3 practical uses: advanced demand sensing for distribution, dynamic disruption simulation for routes and hubs, and creating synthetic data for new logistics services. Remember, as your guide states, the goal of this technology is not to replace your expertise, it's to augment it. Think of generative AI as a powerful assistant that can read everything, run countless scenarios, and bring you the insights you need to make better logistics and transportation decisions. It handles the data overload so you can focus on strategy. Your next step isn't a giant leap. It's about taking that first small step we outlined. Identify one problem, see what data you have, and start a conversation. That's how you begin the journey to smarter, more resilient logistics and transportation.